All right, so can anyone tell me what an example of change in color would be for a chemical change? Any ideas?
Cooking an egg?
No, that would be something else. So an example could be like bleach on clothing. That's totally like different change, right? It'll make your clothes white, right? So bleach on clothes. Okay, and the next one is change in odor. Can anyone tell me? Egg would be an odor because you can smell it, right?
Okay.
Yeah. also with like pancakes, if you're making pancakes, there's a nice fragrant odor. Can anyone give me another one though? Another example? Could be a negative example maybe.
Something decomposing?
Yeah, like rotten food, right? So rotten food. Okay, the next one is formation of a gas. Anyone have any ideas of what an example of formation of a gas could be?
When you mix baking soda and vinegar?
Yes, exactly. And that's, if we have extra time at the end of class, we'll do a little demo called Bubble Bomb. But that's only if we have time. And you guys be sure to write all of this down into your workbooks that I've given you at the beginning of class. All right, so the next one is formation of a precipitate. This is not really, can't really give an example, but any ideas? No, it would just be like, oh, do you have an idea?
When milk curdles.
Yeah, kind of. So it could be like mixing two liquids, like actual liquids, and then mixing it together and it turns into a solid. And then change in temperature. There's two types of change in temperature. Can anyone tell or have an idea of what it is? There's two types.
Is that endothermic and exothermic?
Exactly. And what is endothermic? Anyone tell me?
When it gets colder.
Yes, when it absorbs heat. So that substance absorbs heat. And then what would exothermic be? Yeah, releases heat. And I use, hold on, endothermic, and then exo. So to remember that, you can go, endo kind of like sounds like in, so it's absorbing the heat, and then, which makes it cold. And then exo is kind of sounds like exit, so it's releasing the heat. So it'll be hot. So today, the demo that I'll be doing is an exothermic reaction, and you guys can see why. So, safety first, we'll put on a lab coat. And then we'll put goggles on. You guys can put your goggles on too, if you have goggles. It's not too dangerous of chemicals, and I'm just gonna put gloves on just in case. So I've already poured out, so we're gonna be using 3% hydrogen peroxide. Usually it would work better with 6%, but that's harder to find in pharmacies. So I have to use 3%, but that's okay, it'll still work. So I've poured out 100 milliliters of hydrogen peroxide already. This experiment is also called elephant toothpaste, and you guys will see why too. So I'll just pour all of that in. Okay, and I'll start with, we're also using yeast. And usually the active dry yeast is better, but quick rise can work as well. Just get that in the mix.
What's in there with the yeast?
It's just water, sorry. It's just, just lukewarm water. Just so it can like dissolve the yeast and activate it, I guess. I'm gonna squirt in some dish soap. I'm just gonna give it a little bit more. Give that a nice swirl. gonna add in some food coloring to make a nice color.
Is that just for effect or?
It's just
Okay.
for effect. It's not gonna do anything to the actual experiment. Hopefully it actually turns purple. No, it's blue. Add a little bit more red. Okay. All right, so I'll be pouring in. Actually, if you guys want to come around here and touch the bottle, you guys can see if is it warm, is it cold, is it room temperature? You can touch the liquid.
Room
Room temperature.
Yeah.
Room temperature? Yeah, okay. If you guys want to just stay up here too, that'll be okay. Okay. Now I'm going to pour this in. Yeah, it smells kind of funky, but. Yay! I didn't turn out purple, but that's what it looks like. This is called elephant toothpaste because it comes out kind of like toothpaste, and it's big enough for an elephant. So now, if you guys want to touch it, you can even touch this bottom pan. Is that
Oh, it's hot.
Is it hot? Is it? What does it feel like?
Yeah, it's warm. Oh, yeah.
Yeah? So it turns hot, right? What does that mean? Exothermic, exactly, because it's releasing heat, right? You guys can have a seat if you want. All right. So that was hydrogen peroxide. So that decomposes. I'll write down the formula. So that's hydrogen peroxide is H2O2, and it decomposes and turns, actually, it would be 2 moles of hydrogen peroxide. It'll turn into 2 H2O. What's H2O?
Water.
Water, exactly. Plus an O2. What's O2?
Oxygen.
Oxygen, exactly. So basically this is an exothermic reaction because it released, the energy that released is hotter than the actual product itself. So the yeast acted as a catalyst, or it has an enzyme called catalyst in it, and that acts as, or the yeast, sorry, the yeast has an enzyme called catalase, and then it acts as a catalyst, which speeds up the decomposition of the hydrogen peroxide, and that's why it turns into that. So basically what's in here is just water, and then in the bubbles is trapped oxygen. So the soap just added to the effect of it. I think that is it. All right, yeah, so you guys will have some questions that I'll be giving you guys. Just answer it for next class, and then by the end of the class, I'll have some exit slips as well that you guys can fill out, and then you guys can come and hand it in to me, and we'll be good for the day, okay?
Cool.
Yay!